Hello, hello. This is Postgres FM. I'm Nick, Postgres AI, and as usual, my co-host is Michael, PG Mustard. Hi, Michael. How are you doing?
I'm good. How are you?
Great. Everything's all right. A lot of bugs to fix and incidents to troubleshoot, to perform root cause analysis, as we say, right? RCA.
Sounds related to our topic today, maybe.
Oh, yeah, maybe yes. So the topic I chose is, I'm still not 100% sure how to name it properly, so let's decide together. But the situation is simple for me, relatively. So we help a lot of startups, and at some point I decided to focus only on startups, raised a few startups and helped many startups. I know how it feels to choose technology and grow until some problems start hitting you. This is exactly like usually people choose RDS or Cloud SQL or Supabase, anything, and they don't need to hire DBAs, DBREs, and they grow quite well until a few terabytes of data or 10,000 TPS, that kind of scale. And then problems pop up here and there, and sometimes they come like in batches, like not just one problem but several. And here usually, like for us it's good, they come to us. I mean, Postgres AI, we have still consulting wing quite strong and growing. And we helped more than 20 startups over the last year, which I'm very proud of. And I collected a lot of case studies, so to speak. And I decided to have some classification of problems that feel not good at very high level. For example, CTO level or even CEO, when you think they might start thinking, is Postgres the right choice? Or it's giving us too much headache. And it's not about out of disk space suddenly or major upgrades requiring some maintenance window, although this also can cause some headache. But it's more about problems like where you don't know what to do or you see it requires a lot of effort to solve it properly.
Yeah, I've had a sneak peek of your list, so I like how you've described it. I also like the thought process of whether it hits the CTO or the CEO. And I was thinking, let's say you have a non-technical CEO. If they start hearing the word Postgres too often, it's probably a bad sign, right?
Yeah, exactly.
Ideally, you might mention it once every few years when you do a major version upgrade, and but then nothing bad happens, and they don't hear it again for a few years. But if they're hearing, if it's getting to the CEO that Postgres is causing problems over and over again, the natural question is going to be, is there an alternative? What could we do instead? Or, is this a big problem? So I guess it's these kind of dangers, not just to the startup, but also to Postgres's continued use at that startup.
Yeah, I like the word dangerous here because when you deal with some of these problems, it might feel dangerous to have Postgres for them. Right? It's bad. Like I would like if things were better. Yeah. So I have a list of 10 items.
Yeah.
And we can discuss. And the list is unordered, and I'm going to post it to my social networks so folks can discuss. And I'm like sincerely think that this list is useful. If you're a startup, it's great to just to use this checklist to see how your cluster is doing or clusters are doing, and are you ready? Right. So, Postgres growth readiness checklist. And interesting that I didn't include vertical and horizontal scaling there. I did it indirectly. We will touch it.
Yeah.
But obviously, like this is the most discussed probably topic, biggest danger, like how Postgres scales, like cluster, single primary and multiple standbys, how far we can go. We know we can go very far, very, very far on a single cluster. At some point, microservices or maybe sharding, it's great. But we had a great episode with Lev Kokotov, PG Doc, and it resonates. One of the items I have today, it resonates with what he said during our episode. So anyway, let's exclude vertical and horizontal scaling and talk about stuff which kind of sounds boring often. My first item is heavy log contention. This is very popular. Maybe 50% of companies that come to us have this issue somehow. Yeah. So at some point I decided to start saying everyone, if you have queue-like workloads, or additionally, or if you don't know how dangerous it is to change schema in Postgres, just adding column can be a problem, right? We discussed it, I think, many times. You are not ready to grow, and at some point, sooner or later, it will hit you. And it will hit you as a spike of active sessions. And we know like some managed Postgres platforms provoke you to have huge max connections values. For RDS, like 5,000, 2,500. Why do they do this? Easier for them. But it's dangerous because it creates like kind of performance cliff additionally.
Yeah, it's another version of these cliffs, isn't it? We had another good episode recently.
Yeah, I plan to research this a little bit. Probably we will publish something in this area to prove that it's not good. It's still not good, even if you have Postgres 14 Plus, which has great optimizations for a large number of idle connections. It's still not good not to have.
And there have been some improvements. Like I know a very good engineer who took Postgres down by adding a column with a default, I think it was. But it was there's some improvements in recent years of some DDL changes that are less dangerous than they were.
Yeah, there are several levels.
Yes. Yeah, of course. And if they get stuck if they don't have a lock timeout, for example. In fact, we're probably going to be pointing to episodes on every single one of these bullet points, but we had one on zero downtime migrations that I think is probably the best for that. And we had a separate one on queues actually, didn't we? So
So definitely there are solutions here, and you just need to proactively deploy. It's interesting that I see some companies grow quite far not noticing this problem. For example, with DDL, it's like going to casino. Like you can win. Sometimes boom, you lose, because if you deploy some DDL and gets blocked, you can block others, and it can be disaster. We discussed it several times. And if you had 100 deployments successfully, it doesn't mean you will keep winning, right? So it's better to have, and it concerns me. I have feeling we should implement this in Postgres, like alter table concurrently or something like this. It should itself perform these retries with low log timeout.
Yeah, it's tricky, isn't it? But I agree. But then people still need to know that it existed to actually use it, because I think the main issue here is people not realizing that it can be a problem. And the fact it probably hits users. Let's say you've got a statement timeout. When are you actually going to notice that users have been waiting for are you going to notice that spike on your monitoring? I'm not sure. Like, it depends how many users actually got stuck waiting behind it and had slow queries. So, and it's going to be hard to reproduce. Like, you might not know why it was that. So
log waits is off, so you don't see who blocked you. And it might be auto vacuum running in this aggressive mode, or it can be another session, long running transaction which holds access share lock to a table and you cannot alter it. And boom, you block others. So this is like a reaction chain. So, and it's not good. And queue like workloads, same. Like at some smaller scale, you don't see problems at all. Then you occasionally experience them. But if you grow very fast, you will start hitting these problems very badly, and they look like spikes of heavy log contention, or just heavy log and log in Postgres terminology. It's the same, so just log contention. And it's doesn't look good. So, and suggestion is so simple. Like it's funny that we talk a lot, and people that come to us, actually, they mention they watch podcast. And I say like, okay, Q-like workload, just take care of indexes, take care of bloat, like maybe partitioning. But most importantly, like skip locked, right?
Yep.
And that's it. Like this is a solution. But we spent hours to discuss details. And because it's like when you go to reality, it's not easy to land this. Like there are objections sometimes, but this is what we do. Like we work with those objections and help to implement, right? So yeah. But for everything we had episode. There are episodes for everything. So this was number one, heavy lock contention. And I chose most popular reasons. Of course, there are other reasons.
Yeah.
But in my view, DDL and Q-like workloads, the biggest ones. Okay, next it's boring, super boring. Bloat control and index management. We had episodes about it, maybe several actually. But since, again, managed Postgres platforms don't give you tools, for example, RDS, they did great job in auto vacuum tuning, but only half of it. They made it very aggressive in terms of how much resources, like throttling, they gave a lot of resources, but they don't adjust scale factors. So auto vacuum visits your tables not often enough for LTP. So bloat can be accumulated and so on, and they don't give you resources to understand the reasons of bloat. It's actually not. I'm thinking about it, and I think it's tricky, and it's also a problem with Postgres documentation because it lacks clarity how we troubleshoot the reasons of the bloat. Because we always say long-running transaction, but not every transaction is harmful. For example, in default transaction isolation level, read committed, transaction is not that harmful if it consists of many small queries. If it's a single query, it holds snapshot, it's harmful. So I guess in observability, we should shift from long-running transaction language to X-min horizon language fully and discuss that. Anyway, I can easily imagine and I observe how people think, like MongoDB doesn't have this stuff. Or some other database system, they don't have the problem with bloat. Or indexes. Actually, with indexes, my true belief is that degradation of index health is happening in other systems as well. We also discussed it, right? So they need to be rebuilt.
I was listening to a SQL Server podcast just for fun the other day, and they had the exact same problem. But in the episode where we talked about index maintenance, I think it came up that even if you're really on top of auto vacuum, even if you have it set configured really nicely, there can still be occasions where you get some bloat. If you have like a spike, or if you have a large deletion, or you have there's a few cases where you can end up with sparsely populated indexes that can't self-heal. Like if, for example, you've got even UUID v7 index, and then you have a section of it maybe delete some old data and it's not partitioned, then you've got a gap in your index. So there's a bunch of reasons why they can get bloated anyway, even if you're on top of auto vacuum. So I think this is one of those ones that, yes, auto vacuum fixes most of the problems, but you probably still want to have some plan for index maintenance anyway.
Yeah. So there are certain things that not automated by Postgres itself or by Kubernetes separators or by, some of them automated some things, but not everyone, not everything. Or managed service providers, even upgrades, also like a lack of automation there. We can mention this lack of automation of analyze, but fortunately, future Postgres versions will be definitely fine because dump restore of statistics is implemented finally and goes to Postgres 18, right? Which is super great news. Anyway, lack of automation might feel like, this is a constant headache, but it's solvable. Fortunately, it requires some effort, but it's solvable. Okay, next thing is let's talk about lightweight lock contention. So we talked about heavy lock contention or just lock contention. Lightweight lock contention is also, this feels like like pain and of various kinds. So lightweight locks can be called latches. It's in memory. So when some operations with buffer pool happen, for example, there are the lightweight locks Postgres needs to establish, or working with WAL or various data structures. Also can mention lock manager. So things like lightweight lock manager or buffer mapping or subtrans SLRU, multi-exec SLRU.
Yeah.
When you hear this, for me, like these terms, imagine like there's font like bloody, I don't know, like in red, blood, drops of blood, because I know so like many projects like suffered big pain, like big incidents. So for me, these terms are like bloody terms, you know, because it was a lot of pain sometimes. Like for example, you know, I'm a big fan of subtransactions, right? Just my natural advice just to eliminate them all. Well, over time I'm softer. I say, okay, you just need to understand them and use very carefully. But Lock Manager, a couple of years, remember Jeremy Schneider posted like
great post,
horror stories, and we discussed it as well. So this kind of contention might hit you, and it feels like performance cliff usually. So all good, boom.
Right, is it changing in 18? But it was a hard coded limit, right?
16, you mean this for fast path? Also,
Yes.
SLRU sizes are now configurable I think in 17 already.
Nice.
Well, right, nice, good, but not always enough, because okay, you can buy some time, but still that there is a cliff, and if you're not far from it,
good point.
Again, boom. Or this, I recently saw it, like, remember we discussed 4 million transactions per second?
Yeah.
Yeah, and we discussed that first we found PGStat cache was an issue, was fixed, and then PGStat statements. Okay, PGStat statements, if the transactions are super fast, it's becoming it's bringing observer effect, and we see it in newer Postgres versions as LW log PGStat statements, because finally code is covered by proper probes, right? Not probes, like is wrapped, and it's visible in wait event analysis for observing PGStat activity. So I saw it recently at one customer. I like some layer of lightweight log PGStat statements. So we need to discuss what's happening. Like it happens only when you have a lot of very fast queries, but it can be a problem as well.
Yeah.
But yeah, in performance cliffs, it requires some practice to understand where they are. It's hard because you need to understand what kind of, like, how to measure usage, how to understand like saturation risks. This requires.
I think this
practice.
is one of the hardest ones. I think this is one of the hardest ones to see coming.
After horror stories with LW log manager, every time I see some query exceeds 1000 QPS, queries per second, I'm already thinking, okay, this patient is developing some chronic disease, you know.
That's one I haven't heard. We've done several rules of thumb before, but that's another good one. So 1000 queries per second for a single query. Check.
It's very relative. Also, how many vCPUs we have. If we have less, it can hit faster. Although we couldn't reproduce exactly the same nature as we see on huge machines like 192 cores, 96 cores. Versus we couldn't reproduce that nature on 8-core machines at all. So it's for big boys only, you know. Okay. So this is disease, like, or maybe for adults. So young projects don't experience these problems. Anyway,
that's a good point. Actually, the startups that have hit this, that you've written about and things, have tended to be further along in their journeys. Huge. But still growing quickly, and it's even a bigger problem at that point. But good point. Should we move on? Yeah.
So the next one is our like usual suspect, right? It's a wraparound of 8 byte transaction ID and multi-exact ID. So many words
Yeah.
already said about this. It just bothers me that monitoring doesn't cover, for example, usually it doesn't cover multi-exact IDs, and people still don't have alerts and so on. So it's sad, right? 2 billion
Are you
transactions.
seeing?
It's easy to create these days.
I get
Couple
the
of days.
impression though, I mean, there were a few high profile incidents that got blogged
Sentry,
about. I think,
Mailchimp.
yes, yeah, exactly. And I feel like I haven't seen one in a long while. And I know there are a lot of projects that are having to, I think Adyen have spoken about if they weren't on top of this, it would only be a matter of hours before they'd hit wrapper. It's that kind of
Yeah.
volume. So they're really, really having to monitor and stay on top of it all the time. But I haven't heard of anybody actually hitting this for quite a while. Do you think? I wondered if, for example, there were some changes to. I think it was auto vacuum being like. I think it kicks in to do an anti wraparound vacuum differently, or it might be a lighter type of vacuum that it runs now. I think I remember Peter Gagan posting about it, something like that. Do you remember a change in that
I
area?
don't remember honestly. I
Yeah,
just know this is still a problem. It
of
like
course.
again at CTO level, it feels like how come Postgres still has 4 byte transaction IDs and what kind of risks I need to take into account. But you're right. Managed Postgres providers do quite a good job here. They take care. We had I had a guest at Postgres TV, Hanno Crossing, who talked about how to escape from it in
Yeah.
non-traditional and in his opinion and actually my opinion as well in a better way without single user mode. Um, and since he is a part of Cloud SQL team, so it also shows how much of effort managed Postgres providers do in this area, realizing this is a huge risk, right?
Yeah, and it's not even if it's a small risk, the impact when it happens is not small. So it's one of those ones
Absolutely good
where,
correction. It's low
yeah,
risk, high impact. Exactly.
yes, yes.
Yes.
So I think the cases that were blogged about were hours and hours, possibly even was it even a day or two of downtime for those organizations, and that is then. I mean, you're talking about dangers, right?
Global downtime. Whole database is
Exactly.
down. Yeah.
You're going to lose some customers over that, right?
Yeah. Yeah. Unlike the next item, a 4 byte integer primary keys, it's still a thing, you know. I was surprised to have recently this case, which was overlooked by our tooling.
Oh, really?
I couldn't like realize how come. Yeah, because it was a non-traditional way to have this.
Go on.
Well, it was first of all it was sequence which was used by multiple tables, and
Oh,
yeah, one for all of them, and somehow it was defined so our report in Postgres checkup didn't see it. So when it came, I was like, how come this is old friend or old enemy, not friend, enemy.
old
I
enemy.
I
Yeah.
I haven't seen you for like so many years. And you look differently, you know, because like multiple tables use, but still, like it's not fun. Like, and this causes partial downtime because some part of workload cannot work anymore. You cannot insert.
Yeah.
So, by the way, I also learned that if you just do in place alter table for huge table, it not so dumb as I thought. I checked source code. I was impressed, and this code is from 9 point something, maybe
Yeah.
even before. So if you alter column to change from int 4 to int 8, it actually performs the job like similar to vacuum full, recreating indexes, and you don't have bloat. I expected like 50% bloated, you know,
Oh, why?
because I thought it will rewrite the whole table. I was mistaken. It's quite
Oh,
smart. Yeah, it's of course it's a blocking operation. It causes
yeah,
downtime
yeah.
to perform it, but you end up having quite clean state of table and indexes. Not
Yeah.
quite clean state. It's fresh.
Yeah, it is so that is a table rewrite, no?
Yes, table. Yes, you're right. I was thinking about table rewrite is very dumb thing, like create more tuples and delete other tuples.
Got it.
But there is mechanism of table rewrite in the code. Now I saw it finally. I'm still learning, sorry.
You might end up with some padding issues if you had it optimized well before, but yeah.
Yeah, it also feels like Postgres could implement some reshape like eventually, because there are building blocks in the code already. I see it, and like to first offline style to change column order, and then if you want it, and then fully online style. If PG Squeeze goes to core, right? As we discussed, that would be great. Yeah, I'm just like connecting paths here, and it can be very powerful in like 3 to 5 years maybe. But it's a lot of work additionally. So all those who are involved in moving huge building blocks, I have huge respect. Honestly, yeah. So okay.
And I think this is, if you know what you're doing, this one's easier to recover from. I assume, like with the sequence, for example, you can handle it multiple ways, but you can set the sequence to like -2 billion, and normally you've got a good start.
Everyone thinks they are smart, and this is first thing. This is the first thing I hear always when we discuss this. This was in the past. Like, let's use negative values. Of course, if you can use negative values, do it, because we know Postgres integers are signed integers, so we use only half of capacity of 4-byte capacity. Half of it is 2.1 billion, roughly.
Yeah.
So you have 2.1 billion more, but not always it's possible to use. But this is old story, still making some people nervous, and I think it's good to check in advance.
So much better to have alerts when you're
I saved several companies, big ones, from this, just raising this. And I know in some companies it was like 1 year or a few years work to fix it.
So what was the problem before? Was it looking at columns instead of looking at sequences? Or what was
sequences are always 8 bytes. It was always so, like, if they are 8 bytes. Problem with report, I don't remember, honestly. There was some problem with report. It was not standard way, not just create table and you have default with sequence and you see it. Something else. It was some function. I don't remember exactly.
Okay.
But usually our report catches such things. Yeah. Or you can just check yourself if you have primary keys for 4 byte. It's time to move to 8 bytes, or to UUID version 7, right? Maybe. Okay, that's it about this. Then let's hit up the situation, replication limits. So in the beginning, I mentioned vertical and horizontal scaling, and usually people say there's not enough CPU or something, and disk I/O, and we need to scale, and you can scale read-only workloads, having more read-only standbys, but it's hard to scale writes, and this is true. But also true that at some point, and Lev mentioned it, in our PGDoc episode, he mentioned that in Instacart they had it, right? So like at 200 megabytes per second WAL generation, it's already or 100. I don't remember exactly what he mentioned, but somewhere in that area.
It was a lot.
Well, just 10 WALs per second, for example, it gives you 160. Well, on RDS it's less because they have 64 megabyte WALs. They raised it 4 times. Anyway, 100 or 200, 300 megabytes per second, you start hitting the problems with single-threaded processes. Actually, it wonders me why we don't monitor in like any Postgres monitoring should have with low-level access. RDS doesn't have it, but low-level access. We should see how much CPU, we should see CPU usage for every important single-threaded Postgres process. Right? Val sender, val receiver, logical replication worker, checkpointer maybe as well.
That would be helpful.
Of course, because it's dangerous to grow at scale when you hit 100% of a single vCPU.
Yeah.
And then you need to either vertically or horizontally scale or start saving on WAL WAL generation.
Yeah.
And fortunately, in PG statements, we have WAL metrics, 3 columns, since Postgres 13. But unfortunately, this is query level. What we need also table level to understand which tables are responsible for a lot of WAL. And PG.all activity lacks it. I think it's a good idea to implement. If someone wants hacking, this is a great idea. Add 3 more columns, WAL-based, WAL-related metrics to PG.all tables, PG.sys tables, and user tables. Right? It would be great.
Yeah.
Also, maybe to PG.database as like a global view of things, how much WAL.
Yeah. I've got a vague memory there were a couple of WAL-related new system views introduced.
Oh, yes,
recently,
but it's about... it's about... are you talking about PG.io? No?
No.
WAL related in Postgres 13, it went to explain and it went to PG.statements. This is what happened. Anyway, this is not an easy problem to solve. It's easy to check if you have access. Unfortunately, if you're on managed Postgres, you don't have access. They need to check it. What's happening, especially on standbys. And also, it makes sense to tune compression properly because compression can eat your CPU. Remember we discussed WAL compression. I always said let's turn it on. Now I think let's turn it on unless you have this problem. In this case,
WAL
sender,
close to the limit. Yeah.
You need to check how much of that is WAL compression. And also we have new compression algorithms implemented in fresh Postgres versions. So it's
LZ4
and the ZSTD.
Mm-hmm.
So we can choose better one. For example, LZ4 should be providing similar. As I remember, I saw some benchmarks. I didn't do it myself yet. So it should be similar to BGLZ default compression in terms of compression ratio, but it takes much less CPU, like 2 to 3 times less CPU. So it's worth choosing that.
I looked at it briefly just for our own use for plan storage, and we even got better performance as well. So it won on both for us. Yeah.
Well, you probably saw what I saw, small data on bulk, right? No? Okay, maybe not. Let's move on because there are more things to discuss.
Yeah, nice.
Design limits. So some people already think what they will do when their table reaches 32 terabytes.
Yeah, I guess this and the last one both feel like adult problems again, right? Like there aren't too many small startups hitting the Instacart level of WAL generation or 32 terabytes of data.
So it's a really big clusters, and but we can start thinking about them earlier and be better prepared, right? Maybe sometimes not spending too much time, because like if you spend too much time thinking about how you will bring statistics to a new cluster after major upgrade, but it's already implemented in 18, so just couple of years more and everyone forgets about this problem.
It's the kind of thing that's useful to have like if you've got like a to-do list you're going to be using in a couple of years' time, or a calendar that you're going to get an alert for. Just put a reminder in for like a year or two's time. Just check it.
We also mentioned a few times during latest episodes. This bothers me a lot. First, I learned Cloud SQL has this limit. Then I learned RDS also has this limit. 64 terabytes per whole database. What's happening here? It's already not huge database. So,
but again, in a couple of years, who knows? They might have increased that.
Yeah, well, I think it's solvable. Of course, I guess this is a limit of single EBS volume or disk on cloud, Google Cloud, PD SSD or how they call it. So it's solvable, I think, right, with some tricks. But these days, it doesn't feel huge. 64, it feels big database, right? But when we say
to most of us,
but we have stories 100 plus databases. So all of them are self-managed, I think. Anyone has,
and all of them were sharded. All of those were sharded.
Yeah, 100%. We had a great episode. 100%, 100 terabytes. Where it was Adyen. Who else?
We had Notion and we had
Notion,
Figma.
Figma, right? And Notion and Figma, they are on RDS, but it's a sharded single cluster. It's not possible on RDS, right? And I think Adyen has 100 plus terabytes. No, they
Loads
have
more,
100% terabytes, but it's self-managed.
Yes.
Because on RDS it's impossible, not supported.
Well, and they're sharded also.
Yeah. But yeah, it's in large companies like that, there are always like some parts are sharded, some not maybe. So anyway, when you have 10 to 20 terabytes, it's time to think if you are on RDS or Cloud SQL, is it like how you will grow 5x? Because if you 20 terabytes to grow 5x, 100, it's already not possible with a single cluster, right? Another reason to think about splitting somehow. So, okay. Then a few more items, so data loss. Data loss is a big deal. If poorly designed backups or HA solutions, it can be. Let's join this with poor HA choice leading to failures like split brains. So data loss, split brain. Actually, I thought we had a discussion. There is an ongoing discussion in the project called Cloud Native PG.
Yeah.
Where I raised the topic of split brain and demonstrated how to do it a couple of weeks ago. And good news is I see they decided to implement something to move in a direction similar to Patroni, because when network partition happens and the primary is like basically alone, it's bad because it remains active. And as I demonstrated, some parts of application might still talk into it. This is classical split brain. And I saw, like, based on discussion, I saw it triggered. I never thought deeply actually, but is split brain just a variant of data loss?
Well, I guess you technically might not have lost the data. It's still there. You just have two versions and you're not sure which one is correct.
It's worse than data loss. It's worse than data loss. It's worse because now you have two versions of reality.
Yeah.
And it's bad. With data loss, you can apologize and ask to like bring your data back again, please. And in some cases, we like allowed some data loss. Of course, data loss is really sad thing to have. But sometimes we have it like officially some data loss might happen. The risk is very low, and maximum this number of bytes, for example, but it might happen. With split brain, it's worse. You need spend a lot of effort to merge realities into one.
Yeah. Most cases of data loss I've seen have tended to be at least two things gone wrong, like user error or some way that the node's gone down, but quite often it's user error, accidental delete without a where clause, or dropping a table in one environment.
Well, this is like higher level data loss.
But that can cause the low level data loss if you then also don't have tested backups, and it turns out you didn't have a good. So it's the combination of the two things often.
For me, it's still. Yes. If backups are missing, it's bad. Yeah, you cannot recover. But also, like data loss for me, classical, like lower level, it's database said commit successful, and then my data has gone. Yeah. So yeah.
So that's scary and dangerous as like a CTO.
Undermines trust into Postgres again, right?
Yeah.
If procedures are leading to data loss and also split brains.
Is it actually happening often, or is it more the CTO thinking, I don't want to choose this technology because it could happen?
Depends on the project and the level of control. I'm pretty confident in many web and mobile app OLTP style projects, if they are, unless they are like financial or something like social network, social media, like maybe even e-commerce and so on, data loss happens sometimes unnoticed.
Yeah.
If you have synchronous replicas and failover happen, then the process of failover, like Patroni by default with asynchronous replicas allows up to 1 megabyte. It's written in config, up to 1 megabyte of data loss officially, MB byte. right? So 1 megabyte is possible to lose, and who will complain if it's a social media comments or something we store like comments? We lost some comments, nobody noticed maybe, right? But if it's a serious project, it's better not to do it, right? Or split brain. Yeah. Anyway, this is more not like Postgres does job quite well here. It's question mostly to everything around Postgres infrastructure, and like if it's managed Postgres to their infrastructure, how they guarantee there is no data loss. And last time we discussed the problem with synchronous commit, and we discussed in detail how right now Postgres doesn't do good job not revealing proper LSNs on standbys, right? So even Patroni cannot choose, can have a data loss in case of synchronous commit with remote write, right? We discussed it. Okay, anyway, this feels like something for improvement definitely here.
Mm-hmm.
Good. Corruption. My general feeling, people don't realize how many types of corruption might happen. And it remains unnoticed so much time, like in so many cases. When you start talking, people like reaction sometimes is, wait, what? Like, so yeah, corruption at various levels might happen.
So actually, maybe so in terms of the list where we started, kind of the point of the topic, there was kind of dangers, right? Is this one of those ones that if it silently happened for a while, it suddenly becomes a complete loss of trust of the underlying system? Or
yeah, I as usual, I can rattle a little about how Postgres defaults are outdated. We know data checksums only recently enabled by default.
Yeah,
recently,
great change.
Like month or two ago, right? It will be only
It's
in
for
18.
18.
It should be done over 5 years ago. We saw
Some
evidence.
yeah,
Many managed Postgres providers did
yes,
it, like RDS. That's great.
which is great.
Yeah,
And that kind of is then the default for a lot of people.
Yeah, but it also doesn't guarantee that you don't have corruption. You need to
True.
read. You need to read all the pages from time to time, right? And do they offer some anti-corruption tooling? They don't. Nobody. Okay, they enabled. So what? This is just a small piece of the whole puzzle.
Yeah, and Amcheck improving as well. I think is it in 18?
Yeah, that's great. That's great.
In
Yeah.
indexes as well.
Yeah, big.
In fact, I think we have an episode on Amcheck? I feel like it came up at least once or twice. Maybe index maintenance.
I cannot remember all our episodes. So many.
Yeah, me neither.
But it's great to see the progress in the area of Amcheck. But it's a small piece of the puzzle, and it has settings like options to choose from.
Yeah.
So it's not trivial to choose among options. And also, again, like a couple of episodes ago, we discussed support and how difficult it is to sometimes understand what's happening, right?
Yeah.
And I right now have a case where very big platform doesn't help to investigate corruption, and nobody has like ability to investigate it, but they are not helping. So it was one of reasons I was provoked to talk about that in that episode. So it's bad. It looks like really bad. Like you guys are responsible for that corruption case, and you don't do great job. And I think it's a problem with industry, and we discussed it already. So let's not repeat. But in general, I think if you are CTO or like leader who decides priorities, my big advice is to take this list and like checklist, like evaluate situation for yourself. Better let us do it, of course, but you can evaluate yourself, and then plan some proactive measures, because corruption testing can be done even on RDS proactively. If it happens, you need support, of course, because sometimes it's low level, you don't have access. But at least you will feel control over it, right? So, over corruption. So, anti-corruption tooling is needed. This is what I feel. Yeah. That's it. That's all my list. I'm sure it's lacking something. Like security, more security related stuff, for example. As usual, I tend to lack it. What do you think? Like, was it good?
Yeah, you see a lot more of these things than I do, obviously. But yeah, I think it's a really good list. And with checklists, right? It's not, of course, if
Yeah.
you could go on forever with things to be scared of, but
Yeah.
this feels like if you ticked all of these off, you'd be in such a good position versus most. And obviously things can still go wrong, but these are some of the most, at least even if they're not the most common, some of the things that could cause the biggest issues, the things that are most likely to get on the CEO's desk
Yep.
or in their inbox. So yeah, this feels like if you're on top of all of these things, you're going to go a long, long way before you hit issues.
Yeah. I have a question to you. Guess among these 10 items, which item I never had in my production life?
Oh, maybe. 1 second. Give me a second.
It's tricky, right?
Transaction ID wraparound
Exactly. Yeah, I never had it.
Yeah.
I
is
only,
rare.
well, it's rare, yeah. Let's cross it off. No problem. Yeah, I only like found a way to emulate it, right? Which we did multiple times, but never had it in reality in production. So yeah.
Yeah,
Everything else I had,
yeah.
not once.
I nearly guessed too quickly that it was going to be split brain, but then I was like, no, wait, read the whole list. But I'm guessing you had
Yeah.
split brains like a couple of times, maybe maximum.
Yeah, replication manager, split brain as a service, yes.
Yeah. Okay.
Yeah.
Yeah. Pre-Patroni
Yeah.
days.
Yeah.
Yeah, makes sense. All right. Nice
Good.
one. Thanks so much, Nikolay.
Thank you. See you next time.
Catch you next time. Bye.